And a big hello to everyone in the Goulburn Partnership, to the team. This is Graeme Anderson here. I'm Climate Specialist with Agriculture Victoria, just giving an update on climate variability and change in the Goulburn region. Within Agriculture Victoria, we have a small team that puts out regular climate updates, such as the Break newsletter, which is commentary on seasonal outlooks, the soil moisture monitoring probes. We run a number of webinars and products, which is really about helping farmers and agribusiness make sense of the weather, what's normal, what isn't, and what's next. While we talk a lot about seasonal variability, we also include in that some of those more recent trends. And one of the things we talk about a lot is rainfall. Here's from the Bureau of Meteorology. This is rainfall since 1900 for Victoria, and that's the long-term average. And you can see there's a lot of variability in that longer-term record, and we'll talk about what drives that variability. But also you can notice since 96, from Victoria's point of view, there's only been about 4 years where we've been average or wetter. So we'll just talk about what part of that's natural variability, and also talk about making sense of climate change. Now this is a great long-term record from Benalla, and it goes all the way back to 1883 back here, and this is millimetres up the side, millimetres of rainfall, but this is 1883 all the way through to last year. And the line through the middle here is the long-term average rainfall for that period. So it's 665 millimetres is the average. And you can see some years where it's quite wet, over 1,000 millimetres, and other years where it's quite dry, only less than 400 millimetres. And you can see sort of there the 2006 drought. So a lot of variability in that record. You can see around the Federation there was a run of dry years, also World War II. Probably a few decades post the 50s that were quite wet, and then the millennium drought you can sort of see there in those dry years. So a lot of variability in there, and we'll talk about what's driving that. Also we have here is that Benalla rainfall record, but this is just looking at that long-term record since 1883 for the summer season of summer, the season of autumn, winter and spring. And you can see a lot of variability there. You can see that recent very wet summer in 2010-11, that was the wettest summer on record. It was for all of Victoria, broke our previous wettest summer by almost a third, very wet year. We can see autumn rainfall, and perhaps one thing that happens across a lot of Victoria is that we've probably had a few more drier autumns thrown in the mix there since the mid-90s than we have longer term. Winters there, probably a lack of some of those wetter winters that we're having earlier in the record when you look there. And spring, certainly in the last 10 years, we've had more than our fair share of drier springs. So that's all part of that variability, and we'll talk a little bit about some of the trends. What's behind good old-fashioned variability? Well, this is one of my favourite pictures. It really shows the key sort of global drivers that affect those wetter or dry years in this part of the world. And basically, to make it rain in Victoria, we need two things. We've got to have a good source of moisture, and most of that moisture actually comes from the warm tropical oceans up here, which feed in, and it varies from year to year, but it feeds in warm tropical air, it's full of moisture. And what happens is that if all you had was moist air, it would just be humid. So you need cold, that moist air to hit cold, and that's where you can see here the southern annular mode. Really strong climate driver. Strong winds whiz around the Southern Ocean, and it drives these sort of cold fronts, and they flick their tails across southern Australia. So it's that combination of where moisture feeds in, but where it interfaces with that cooler air down south that gives Victoria a lot of its reliable rainfall. And up here we can see there's the El Nino Southern Oscillation. So some years the Pacific Ocean can be in a more helpful mood, such as when it's in La Nina phase, and when it's doing that there's warmer water here generating lots of extra cloud and moisture, and that feeds into our weather patterns. So often that's a wetter season. And when it's in not so good mood in El Nino years, all of the warmer water and the extra cloud and moisture is out in the central Pacific or out towards South America, and it means there's very little moisture that feeds into our weather patterns. So it's a key part of our variability from year to year, always has been. And there's also this one, the Indian Ocean Dipole. Last year was a really good example. Really warm water in this ocean up here, creating lots of cloud, feeding into these northwest cloud bands that fed into our wetter than average year. Really strong driver for Victoria's seasons, but also too we can have dry years when all of the extra moisture is over towards central over off Africa. So these two are really behind our bigger droughts and our bigger wet years. In 2006 drought we had an El Nino here in the Pacific, and the Indian Ocean Dipole was also in its drier phase. So when they're both switched off, then that makes it hard to feed into moisture. So a lot of that is really around that seasonal forecasting, what we do. 2010, the spring of 2010, we had a La Nina in the Pacific, lots of moisture coming in, lots of moisture from the Indian Ocean as well, so that teamed up and there was moisture galore to feed into our weather patterns. So they're pretty useful, and there's a lot more farmers really getting in and understanding these seasonal forecasts. Now what we've got here is basically a picture of sea surface temperatures. Now along the equator here the water's a lot warmer there than it is down here near the poles, but what this particular image is showing is where areas of ocean might be warmer than its long-term average, such as these colours here, or cooler than its long-term average. So what we're looking at here, and a lot of farmers are now looking at this in seasonal forecasters, is looking at where is the warmest water sitting along the equator. Now this is an example of a dry pattern. It's looking back to September 2006. There was an El Nino in the Pacific, so all the warmest water was over here, generating lots of cloud, lots of rainfall and floods and everything happening then. But you'll notice this particular part north of Australia, the sea surface temperatures were cooler than average. And when that's happening, both here and also over in the Indian Ocean, when we've got the cooler water on our side, that just means that there's less cloud being generated here and less moisture to feed into our weather patterns. So that's one of the sort of signals that forecasters look at to see, from year to year, where's all of that really warmest water up here generating the most cloud and moisture. Now if you keep an eye on this area just to the north of Australia, have a look at what it looks like in a wet pattern. We'll go and have a look at the spring of 2010-11. Okay, so you can see quite a difference there. This is October 2010, a big La Nina in the Pacific, the warmer water here, so all of the extra cloud and everything. We've got the Indian Ocean Dipole also, really warm water here. So just means there's lots of warmer ocean, lots of extra cloud feeding into our weather patterns down here. So that's sort of that longer term correlation between those oceans and how much moisture they're feeding into our weather patterns from one year to the next. And this was just an example from October last year, and you can see that there was a La Nina trying to get started last year, but importantly we still had that warm water, warmer than average around us up here, and the Indian Ocean, this was really warm water up here and it was feeding in plenty of moisture last year. So that was why last year was quite wet. We had that sort of condition. So seasonal forecasting a lot is about working out where all the action is going to be from one year to the next. And from our point of view in the Goulburn region, really it's the sort of winter and spring period when that if there's plenty of extra moisture happening up here, that's when it more reliably can get to us down in that winter and spring period. And we're just looking at here, this is looking at previous El Nino events and what's been the sort of traditional rainfall patterns when we've got an El Nino, and these colours are sort of the drier years. When we look at what's happened at Benalla during previous El Ninos, this is just looking at the rainfall record, and there's been 32 El Nino events in that long-term record at Benalla. So long-term, normally a third of the years are dry, decile 1 to 3, a third are yellow, which is sort of average, and a third are blue, which is decile 8 to 10 years. But when we just pull out the 32 El Nino years, and we look at that August to November rainfall at Benalla, you can see that rather than just a third of those years being dry, actually, 3/4 of them were dry. So El Nino has quite an effect at Benalla. It doesn't guarantee dry. Not every El Nino has been dry, but it certainly does increase the chance of a dry spring. And when we look at a La Nina, when there's extra moisture coming out of the Pacific, you can see here rather than a third of those years being wet at Benalla, almost 2 out of 3 were wet. And so you still can have a dry season at Benalla in a La Nina, but certainly it increases the chance of wetter. So it's a good example, and it really does have its fingerprints all over our wetter and drier springs in the region. Looking too at the Indian Ocean dipole. So this is when the Indian Ocean dipole is in its drier phase, less moisture coming from the northwest up here. It's got a drier signal, and at Benalla, when we look at that signal, it does increase the chances of drier a bit, perhaps nowhere near as strong as El Nino. And like last year when the Indian Ocean dipole was in its wetter phase, quite a strong effect down here in Victoria, and you can see at Benalla, whenever the IOD's been in that wetter phase, more than half of those August to November periods have been decile 8 to 10. So it's quite a driver, especially when it decides to fire up in the wet phase. Now, a lot of what I've talked about there is just good old-fashioned variability, and the question is there anything happening now that's a bit different to what's happened in the long-term record? Well, one of the things that is a bit different is about temperatures. This is Victorian temperatures from since 1910, and this is summer temperatures right through to last year, autumn temperatures, winter temperatures, and spring. And you can see there, certainly in the last sort of 10-20 years, we've had a lot more years above this sort of long-term average temperature. And especially when we look at things like winters, milder winters, and I know I talk to a lot of farmers and say can be a good thing because we get improved pasture growth and milder winters, but also has other impacts such as milder winters can allow some of our pests and bugs like fruit fly, which might have once not survived so well over harsher winters. When we get milder winters, some of those things can overwinter better and give us some bigger problems. One thing probably that a lot of farmers point out is when we look at the last 10 years of spring temperatures, we've had quite a number of springs that have been sort of 1 to 3 degrees warmer than average, and that's quite a big variability. So the Bureau has sort of explained that with climate change, largely we're going through the process of squeezing in an extra month of summer. So that's really quite different. So while we've had long-term variability of rainfall, and we'll continue to have that, this sort of climate change, one of the key things is this increasing temperature. You'll note here that last year was pretty close to an average spring or just a slightly cooler, and that was really an important part to why we received such big yields in a lot of our crops, because temperatures are a really important part of how our crops sort of go, especially in that spring period. So one of the issues really is just about this spring variability and the role temperature plays in it. Also, one other thing that's a bit different, the Bureau taking measurements of pressure pattern, and across southern Australia, basically since 1950, the pressure pattern here is getting a bit stronger. So, as things have been getting warmer, that pressure pattern's basically been getting stronger in our part of the world. So that certainly isn't just good old-fashioned variability, and that's something that I expect to continue. And this is just looking at pressure pattern. Again, this is from the Bureau. This is looking back to 1950 through to last year, or the end of 2015, sorry. And you can see here that some years we have higher pressures over this area of southern Australia, and some years it's lower. And quite often it can be teamed up with El Ninos and La Ninas, and you can see here that was an El Nino. There was another El Nino 2006, and so you expect that to happen. But what's I guess one thing is the variability, which is when we've got higher pressures or lower pressures. But you can see clearly there that every 20 years or so, whenever another strong El Nino pops up, we're getting into higher pressure territory, and so that's basically the difference between variability and climate change. Climate change is the trend line. And one of the surprises that's been there is that while our springs have been getting warmer, one of the issues of August to November frosts and been work done by the CSIRO is showing that in some areas we've actually been getting increasing frost risk in spring. So some of our crops and plants, when they're getting warmer daytime temperatures, are wanting to flower earlier, but because of that higher pressure pattern, and when we get high pressures, clear skies and clear night skies, it can actually be quite conducive to frost. So that can be a particular challenge, and we've seen a bit of that, and it's an example of some of the surprises that are in store as the climate system starts to change a bit. One of the things when the climate scientists look at the long-term models, this is the longer-term projections when they feed in increasing greenhouse gases into the atmosphere, and they're saying, okay, well, the climate gets warmer, and this is looking at rainfall, and this is looking about what do the models think in the future, if the world gets warmer, what percentage of models think that which parts of Australia might get wetter versus percentage of models saying, well, if the world's a bit warmer, there'll be less rainfall. And you can see here from this that a warmer world, some of the models are thinking that, well, it's a bit more likely there might be some more moisture as the tropics expands up here in Northern Australia. There's a lot of the models could go either way in these sort of areas, but for Southern Australia the models seem to be fairly confident that warm world means drier. And why is that? Well, it's basically saying, well, it's this pressure pattern down this part of Australia that has been getting stronger, and the climate models just expect that to continue as the world warms up. And it's interesting over here, this is just looking at that sort of growing season, April to October rainfall since 1997, just showing that really we've had a run of the dry years there because of that higher pressure pattern. So that's what's happened since 97, and this is sort of what the climate models expect longer term. So I guess it's largely doing what they expect to. The uncertainties really are around the type of variability that happens and how quickly some of this might unfold. So there's still quite a bit of uncertainty about what we might see in the next 10-20 years around this broader trend of increasing temperatures and perhaps increasing variability. And this is a bit of work done last year by Dave Stevens, looking at the seasonality of Australian rainfall since the year 2000, so really the last 16 years. And there's we've got areas which is summer rainfall dominated through to uniform throughout the year through to winter dominated, and basically looking at rainfall in the last 15 years, just showing compared to long-term average, is that seasonality is largely shifting south. So one of those things is those sort of uniform areas, they've been shifting south, and that's largely a really good way to explain overall climate patterns, is that as the world warms up, basically the climate zones and that some of that seasonality shifts south, and a lot of our farmers have been noticing that. And it's interesting too, in this sort of discussion, a lot of farmers say, well, yes, our local climates are changing, but also we know that there are farmers all over different climate zones that are farming quite successfully. So we know that it can be done. It's just that the changes required as farming systems have to adapt as those sort of weather patterns to our north come shifting south. And this is sort of a lot of the great work that's been happening across agriculture in the past sort of 10 years, and a lot about insights for what's needed in future. So ingredients for success, we need a modern flow of technologies, research and development, improved genetics and innovations which can be applied on farms, which farmers have been doing, and we just got to make sure that flow keeps coming. Also, there's a lot of improved on-farm and also regional infrastructure, whether it's around the storage of water or fodder or communications, transport, those sort of things. They're all really key things that feed into how we cope with any future changes in climate. This growth and connection in both local and export markets, and also maintaining biosecurity to keep export markets open. This is really important, and we've seen that just in recent years, just with higher value markets, say for some of the livestock industries, how that's a really important buffer for how we get through tight seasons, because the more farmers are profitable and making money out of things, the better they can actually, better equipped they are to deal with tougher seasons. And we've just seen that, when milk price is low and the issues for dairy farmers, when profitability is poor, it makes it even harder to deal with tougher seasons. So at the heart of it is about international competitiveness and making sure that people are making money. Business management for variable years and income, a really key thing for all businesses, because we're not just dealing with variable years from a rainfall point of view, but also from a market point of view and trade. So this is really an increasing skill to manage this sort of volatility of markets and climates. A lot of amazing things going on with regards to farm planning and conservation tillage, management of soils, improved pastures, and land care and NRM skills. Like, I guess all of this is getting a lot better, and as we have sort of droughts can be quite damaging to soils, but we're certainly seeing a lot of farmers are really managing droughts and maintaining soil cover much better than perhaps what was happening in the 80s. And another of the key bits, really, it's all about people and how we surround ourselves with networks, support networks and knowledge channels, and all the information that people are needing to give them the confidence to invest and grow their businesses. So they're the sort of recipes that are in there, which I guess are all needing to be happening to help us as we manage and adapt through a changing climate. And a lot of farmers saying, well, when they're looking at change pathways, there's sort of a few different layers of change. There's the first decisions, which is really decisions we make and tweaks we make to our system as we go. But then there's the next level of decision, which sometimes these decisions are a bit more complicated. They might cost a bit more, or they might have more knock-on effects. If you change one thing on a farm, then it changes a number of others. So it's interesting. This is just a different way of looking at we can make those easy decisions for a while, but then sometimes we've got to make bigger decisions to adapt, as we're dealing with water security issues more often. We have to invest more in how we solve that at a farm level. And then there's also, we move into some of these tougher decisions, which is around needing to adjust or change enterprises or major investments in infrastructure, or even just those issues about that some people leave or exit farming and seek other employment options in agriculture. So all of those options are there, and a lot of farmers tell me that, well, these are the options that have always been there for agriculture. So I guess part of it, in terms of understanding the services for the region, we're just trying to make sure that all of those pathways are there so that people have got a brighter future no matter which option they pick. And I guess just in sort of closing, in thinking about climate change, is probably the 3 Ps of climate change are worth thinking about. And often what I've talked about here most of the time is dealing with the physical effects of climate change, which is really what the actual weather does. And most people believe there's changes going on with the weather, and some don't. But either way, we've got to deal with what the weather does. But there's also a couple of other important elements, and one of the P's is around policy. That as a result of dealing with climate change and increasing variability, there are a lot of policy implications for changes or reform around issues such as water, energy, renewables, carbon, bushfire response, planning, drought support, transport. All of those things, really, whether you believe in this, whether climate's changing or not, doesn't really matter, because there is a lot of policy responses which can have big impacts on either an individual business or an industry or a region. So it's really important to think about these different layers of how climate change might impact. And also the other particular area is around how others respond, and we were saying people, and that might be how consumers responding, how banks, insurance, how trade markets, supply chains or investors might be responding. That irrespective of whether you believe the climate's changing, these sort of decisions made by others can really impact on either your business or your region. So this is a useful sort of lens to think about when you're trying to think through what we're trying to prepare for. And I guess importantly for every region is a real strong need for local sense making. So that's really working with people, learning and responding to these sort of changes as we go. And that's probably the way it's always been, but I think it's just really important now. We've got lots of improved ways of doing it, but it's going to be a really key bit to how we manage the extra changes thrown in with climate change. So that's a pretty quick summary. Quite happy to come and speak at agribusiness forums up in your part of the world. And if anyone's interested to get those monthly updates on the seasonal outlooks, just drop us an email to the.break@ecodev.vic.gov.au. So I'll leave it there. All the best.